We are starting up the next chapter, that's basically agent communication. So in our previous lectures we have seen the basics of agents and what are the different architectures of agents, and now this is how basically the agents will be communicating with each other. Now this particular chapter has been actually written by Anup Chopra and Mohinder Singh, who have specifically worked on agent communication in a multi-agent environment. Now when I take a multi-agent system, it's basically I consider a distributed system. So a distributed system is basically when we will have the systems being located in different locations. Then in that case, the agent's property which would be required would be autonomous as well as heterogeneous. When I talk about heterogeneous, so heterogeneous is wherein since the agents are being distributed in nature, right, the data which they will be interacting with would be independent of each other and they will be located in different locations and they will be of a different data type altogether. Now the property of autonomous, as it has already been discussed, is basically acting independently. Now agents communicate with each other, and when they are communicating with each other, obviously they need a certain set of protocols, right? I mean, if we humans also will be speaking to one another, we will have certain set of protocols, right? So similarly, the agents also have certain set of protocols which defines how the agents would be required to be communicating with each other. Now, defining a protocol basically helps to ensure that they can be interoperating with each other and hence working together. And a protocol is basically modular and it is reusable. So it's not basically designed for a specific application. It is designed such that it is reusable for any particular application as well as it's modular in nature. Now, many communities of practice define appropriate set of protocols. Like for example, we have the healthcare HL7, we have the foreign exchange transactions, and we have the Rosetta Net. Okay, so these are the communities which basically define appropriate set of protocols which would be required for the agent communications. Now, the objective of this particular chapter is that when I define protocols, what are the main requirements of a protocol specification? How is it that we specify a communication protocol and which way is this field moving towards? Now, when I talk about your traditional distributed computing, at that particular moment of time, we would be ignoring the autonomy and the heterogeneity, right? And we specify the interaction being present at the lower level, right? That is basically messaging uh, each other in the particular distributed environment. So what we would require is we would need to specify the interoperability in the low level terms, and a system may be fragile because of its interoperation depending upon the lower level details that can easily change when one of the parties modify its internals. So when I talk about the traditional computing, yeah, so this was the you know the difficult part of it. That's because the system would become quite fragile because it would be depending on the low level details and those particular parties. If they modify the low level details or the internal details, then in that case it would obviously affect the interoperability, the communication with each other. Now when I talk about autonomy, right, basically that's what is the property which is required from an agent, right? The program which is autonomous. Now each agent is basically free to act as he wishes to, right? So we must design a particular protocol so that they do not over constrain an agent interaction, and intelligence is irrelevant in a particular protocol, right? So protocols generally do not require any intelligence, right? So must design a protocol whose correctness does not depend upon the agent's internal reasoning. So whenever we decide a particular protocol, the protocol need not be intelligent, right? It's only designed such that it does not depend on what reasoning does an agent do internally. Now the agents are the logical units of distribution, and the physical distribution is based on the consideration, like for example your geographical distribution, the throughput, the redundancy, and we cannot treat two or more agents as a single operating system process, even though that's how they maybe you would be realizing them, right? So example, within the same virtual machine in an agent platform. So it's not necessary that we need to treat two different agents as two different processes, right? Okay, so in traditional systems, it is enough that protocols will specify what are the schema of the messages which is exchanged as well as the legal flow. But in the case of multi-agent systems, the protocols must also specify what is the meaning of the messages which is going to be exchanged, right? And logically agents interoperate on the basis of the meaning of this particular communication. Since the meaning basically determines that what is their state of interaction. Whatever is in the protocol becomes a standard to which the agents are implemented, and it defines a level of heterogeneity. That is, the agents can be heterogeneous with regard to everything else. Giving prominence to low-level concerns such as ordering and occurrence of messages couples the agent's design at the corresponding low level, even though such concerns are appropriate for low levels of the implementation. So, whatever is the protocol, right, it becomes a standard to which the agents need to adhere to, and they define a level of heterogeneity and giving the prominence to the low level concerns. Okay. Next, coming to the finite state machine representation. Now, part of a purchase protocol that deals with making offers. Okay, so here it is that we have two different roles, that is the buyer B and we have the seller S, right? So if I have these particular transition labeled with messages, okay, they basically specify the legal message flow which is happening. So you have this S0, S1, S2, S3, right? So when it is transiting from S0 to S1, so there is an offer. Then if that offer is rejected by the buyer, right, then it goes to the other state. If it is accepted, then it goes to the other state. And then finally it gets updated. Yeah, so that's what is basically the finite state machine representation. Now, the FSM specification does not account for meaning of these messages, and implicit meanings can cause violations of interoperability because the parties may interpret the messages differently. So designers agree offline regarding the meaning and thereby limiting the heterogeneity of the particular agents. So the FSM specification does not actually take care of all the message exchanges which take place, right? And what these particular message exchanges mean, that needs to be agreed upon offline by the designers. Okay, so that there is a limiting that the heterogeneity of the agents is followed. Now, the criteria for evaluating protocols. Software engineering of systems basically use representations which are close to the stakeholder requirements. Then the next criteria is that there should be a flexibility of agents and compliance checking of an agent with the particular protocol. Now, if we define a particular protocol for agent communication, but it needs to be checked also, right, when the agent is operating along with the particular protocol, right? So the software engineering of the system is that it uses the representations, which is basically close to what the stakeholder requirements are. Second is that there should be a flexibility of the agents which is there, and then next would be a compliance check of an agent. Now, according to the Communicative Act theory, communication is basically a form of action. So it is going beyond what the traditional logic is, which basically deals with only a true and a false. Okay, let's take for example when the judge declares a couple married, the judge does not merely report on some privately or publicly known fact. It brings the fact into existence, and the assumption is that the judge has suitable powers and can act autonomously, right? So, if uh, a particular couple needs to be declared as married, okay, then in that case it is assumed that the judge has been given that many suitable powers that it can act independently of itself. It does not just report it privately or as a publicly known fact. So it's a fact basically brings that fact into existence. Okay? So the above is basically an example of a declarative statement which you can say. All communications can be expressed as declaratives. Okay. So as we've seen in the previous example. Next is we have informatives. Okay, like for example, if I have a statement that the shipment will arrive on Wednesday, maps to. Okay, I inform you that the shipment will arrive on Wednesday. Okay, so it's basically giving you an information. When I have a directive type of a message, right, or a directive type of communication, which is so it is like send me the goods. Okay, so it maps to I request that you send me the goods. When I have commissive type of communication, then it will say I'll pay you $5. Maps to that I promise that I'll pay you $5. Okay, so these are your different communications. Under your declaratives itself, which is being classified as informative, directives, and commissives. Now, when I talk it with respect to multi-agent systems, emphasizes basically autonomy of the sending agent, which is basically regarded as the speaker, and it may not control the real world, but it controls when it informs requests as well as promises. Okay, so the speaker agent, which is or you can say the sending agent, it is not going to control the entire real world, right? But what it does is it is going to give the information, it is going to give the request operation, and it is going to fulfill the promises which it has done. The performative provides type information on the communication separately from its content. Suppose if I consider the proposition that the door is open, right? Uh, there are different ways in which I can put this particular statement. As I inform that the door is open, I request that the door is open, I promise that the door is open. That is, we see a modular structure separating the types from the particular content. Okay, so as a result of which these messages come under your different categories. Okay, when I say when I inform and I request and I promise. When I promise, it becomes like a commercial, right? And when I just say I inform that, right? So it's okay. So when I talk about agent communicative primitives, it says that it is customary to consider a small set of primitives which are based on the performative types. Okay? And the above proves problematic since mass applications are diverse. Right? So I cannot just have a limited set of primitives which can just be based on certain performative types. Okay, and it also proves problematic because the standard broad brush meaning is rarely adequate, and the developers build additional layers of meaning but leave it undocumented. Now, dispense with a fixed set of primitives, define application-specific primitives, provide suitable meanings based on social state primitives such as commitments. Now, when I say that the message exchange which should be happening between the agents, okay, then we can say that there is a set of fixed set of primitives wherein it will be more for an application. So it defines application specific primitives and provides suitable meanings. So it provides suitable meanings based on whatever the social state primitives such as commitments.